Hi, I'm Paul Moeller. I'm a software developer at RadiaSoft, and today I'll be talking about UI user experience, hierarchical data entry, or how to design easy-to-use UIs for editing dynamic data structures. This talk focuses on several UI patterns, which build manageable editors over complex data, which have interchangeable components. I'm part of the software group at RadiaSoft, and one of our recurring challenges is building intuitive user interfaces for scientific codes. One of our recent projects has been creating a web interface for the OpenMC Monte Carlo neutron and photon transport code. The OpenMC data structures were particularly challenging due to their interchangeable nature. This webinar demonstrates some of our approaches to implementing application data entry forms while avoiding common pitfalls such as multiple nested pop-up windows or requiring mouse clicks during data input. We'll look in detail at the two examples shown here, a UI for building material components and another UI for defining a radiation source's spatial geometry. Here's some of the goals that we'll aim towards. We'd like to minimize mouse navigation and avoid pop-up windows when editing details. We'd like to clearly display nested structures and provide a simple software implementation. For example, if we have a tree-like data structure, we don't want to resort to showing pop-up dialogues for each node in the tree. Here's an overview of what I'll cover in this webinar. We'll look at mapping data onto editors for a variety of data structures, including one-to-many and hierarchical tree-like data. We'll cover cases where the child models may be of different types, and hierarchical examples where sections may be swapped out with different models. Let's start with the basics. A model is a collection of data fields similar to a record in a database. Models may refer to other models, as in this case where a person has an address. In this diagram, the green box represents a model, which is made up of fields or references to other models. A gray box is a single piece of data, such as a person's first name or a city. Creating a UI editor for this structure is simple. A flat mapping is made from the data to each form field. Another common model relationship is one-to-many. In this example, a material model is made up of some fields, name and density, and a list of elements, which each contain their own fields. A tabular editor is ideal for this relationship where the elements can be added and removed easily from one page. But what if the sub-elements can change? For example, what if a material could be made up of a combination of elements and nuclides and elements from a formula and thermal scattering? A simple table will no longer work. This is an example of a one-to-many with disparate children data structure. A solution would be to base the row's contents on the selected component type. Selecting a specific type would display the appropriate columns for editing. For example, here, an element component type was selected from this list. And all the fields related to an element model are displayed in that row. Building the material components in this fashion allows you to view and change all the subfields within one panel. For example, the definition of water with a single nuclide and an element and a thermal scattering property. Here we see the material editor in action, adding high-density polyethylene. Notice that the mouse isn't required for data entry. All component information can be entered by typing and tabbing across the fields. Building the subcomponents in this fashion allows for fast data entry, easy review, and avoids using pop-up windows and mouse navigation. The editor automatically expands to allow entering large sets of data, such as this example. Who knew concrete was made up of so many things? But what if the sub-elements themselves had fields which contain dynamic data structures? What if the sub-elements also contain tabular data? How would you edit a dynamic tree-like data structure? One example of this is the data structure for defining the spatial distribution of a radiation source. It could be a single point in space, radiating outward in all directions. Or it could be a complex structure specified by probability distributions across a selected geometry. Now imagine if the distributions for each of the axis properties could be interchangeable. For example, a normal distribution could be used to describe the spatial properties along the z-axis, or a power law, or a Maxwell distribution. This is an example of an interchangeable hierarchical data structure, where changes in the spatial and probability distribution dynamically change the UI layout. In this case, we want the user interface to reflect the selected spatial distribution, but also delimitate the subfields from the parents' fields. We'd like the user interface to be simple for the box and point case, but allow for interchangeable probability distributions for the more complex geometries. The UI editor for this is also driven by the selected field. In this case, the spatial distribution of the radiation source has many different options. Selecting a point distribution and appropriate fields are presented and easily edited. Selecting a cylindrical independent distribution, and the static field, such as the origin, is shown, along with the dynamic subfields, such as the radius distribution. Each distribution can be independently selected and edited. And here is the completed definition for this source geometry. Grouping fields within the shaded boundary shows a nested structure with lower sublevels displayed with a darker background. And this pattern of nested type to field editor shows up in other parts of the application. Here for the angular and energy distribution definitions. Now we'll look at the implementation details for the interchangeable hierarchy pattern. First off, we'll need a simple static definition of the models and fields. The model definition would map a model name to a list of fields, field metadata, which includes the field name, the UI label, the field type, and possibly a default value. The view definition would contain an ordered list of fields to display when a model is selected for editing. We'd also need a field editor factory, which can take a model and a field name as input and return a UI component which can edit the value. For example, if a model field has a field of floating point type, the float editor might be returned a simple HTML input element. Alternatively, a more complex field editor could be returned, which contains an aggregation of subcomponents. This is a subset of the static configuration for the radiation source I discussed earlier. The source model has a space field with the type spatial. Here, a point model is a type of spatial model and has a single field to define its location in space. The enumerated type spatial distribution lists the spatial model names along with the labels to show in the UI. And finally, the AngularJS field entry, which maps the spatial type to a specific AngularJS directive named multi-level editor for editing the subcomponents. We'll look at the implementation for the multi-level editor directive next. All right, the multi-level editor directive is about 70 lines of code split into an AngularJS template shown here and a JavaScript controller. The template defines the styling and layout of the fields and makes use of multiple calls to the field editor factory for creating subcomponents. For example, this is the type field that's shown, and when the type field changes, the related model fields are displayed here in a list. In particular, the styling on the outer panel uses an opaque background, which will automatically darken as sublevels are nested. The JavaScript for the multi-level editor simply watches for changes in the type field, and when it changes, it rebuilds the list of fields to show in the UI based on the ordering contained within the view definition. Here, we watch the type field for changes. And if the field's being edited and it changes to something new, then we create the submodel and set its default values. Then setView is called to arrange the field information in a format which can be used by the template on the prior slide. This implementation allows for nested structures to be edited, such as the cylindrical spatial distribution's radius probability. In conclusion, we've looked at several different patterns for editing different data structures. These patterns can be applied to many different applications, but the examples I've shown in detail have come from RadiaSoft's Cerepo Cloud MC application. And that's the end of my talk.
Awesome. Thank you, Paul. I appreciate that talk. You did a great job. And I'm going to go ahead and get into our question and answer session for today. So our first question is, how is the material editor used within the application?
All right. So I can show an example of that because I have the application running here. Okay, so here's an example of the Cloud MC application running, and we've got
okay, we're not actually seeing your screen, Paul. Can you go ahead and click the share screen again so we can see
I will click share screen. There we go.
Thank you.
Yep, I love this stuff. Okay, so can you see my screen now? How about?
Yes, I can see your screen now. Thank you.
Awesome. Okay, so here's the Cloud MC application, and so how do we, and this is a example with a molten salt reactor, and we've got basically 4 different volumes that have, and each of them will have a different material assigned to it. So in this case, the material editor is brought up per one, and like, for example, here's the definition for the salt material. You've got, various elements and nuclides, and if you need to add a new one, you can just come in here and add an element, and whatever it would be, or perhaps even add a nuclide, and it does a low level of validation in that, like nuclides require numbers, so you could have DE something or other, perhaps. There it goes. Okay. Or maybe it's, yeah. Anyway, so you get various level of editing here, and that's it. And then you can come in and look at each of them. So for example, here's another structure within it with totally different set of elements and nuclides. That's the end of that question.
Okay, thank you very much. Next question in the queue is, why is the GUI that you're setting up better than editing this text in an input file for a project like this?
Right. So, okay. So what's the advantage of having a GUI for this? And actually, I've got an example for this. Here's a different structure. We're looking at a reactor. It's got a lot of different volumes, and then you can come in and say, the blanket has some definition. Maybe it's something from a formula and so on. If you were going to write this in the code itself, I have that handy somewhere. Right, so if you were going to, like this is the example I took it from when I was building up the model, you would have to name everything carefully, set densities, all of this sort of code is a little bit cumbersome to enter. And so you'd have to enter all your materials, make sure you've got them all named, build them into a list, and then do it. And so in this case, it just makes it more manageable where you can basically have everything that you need on one page. And for these examples where there's one material per, or one element per material, it's not necessarily as advantageous, but certainly in cases where you're dealing with something like concrete or molten salt or something to that effect, it becomes nice to have it in a table where you can kind of get a good overview. And you don't have the typing errors or worry about how it's going to compile or anything to that effect.
Excellent. Thanks, Paul.
Sure.
All right. So again, we're right at our 20 minutes that we were shooting for today. So thank you everybody for attending our webinar. I've put a couple of links in the chat to our YouTube channel where this video will be posted later for your reference. You can also check out all of our other library of content there. We do a lot of these webinars and have some interesting topics that you might want to reference. Also, please join us in our Slack workspace at slack.swappable.com. And you can chat there with other users of Swappable and get information and support about this platform. If you have further questions, please reach out to Paul or any of us here at RadiaSoft. That's Paul's email address there on the slide. And we look forward to seeing you in our next webinar. Oh, wait, I'm sorry. We have one more question. Paul, do you have time for another question?
Yeah, of course.
Oh, okay. This one just came in at last minute here. And the question is, do you attempt to model your UI based on popular websites? For example, selecting items that could be based on a shopping cart for the benefit of familiarity for the user?
Yeah, so that's a good question. Let's see, what's the best way to answer it? We tend to create our applications generally with the idea that you're working from panels of information. So like maybe if I was looking at the visualization, where you deal with things on a panel by panel basis. So like in this particular application, there's not a whole lot of different sections. Like in SRW, for example, you might have a different panel for editing an undulator and a different panel for editing an electron beam, for example. So sort of our approach is to get things into manageable pieces and then have panels that then let you edit them. And I guess I can show a quick example here, perhaps. So here I'm bringing up our SRW application, and I'm going to look at the CHX beamline. And so, for example, here we've got several different reports that are running, but everything about the electron beam would be contained within this panel and then the details for it. Likewise with the undulator and so on. And then for example, each report has details where you can edit, what kind of information you want to plot. So I guess it's less of a shopping cart sort of idea and more of trying to split applications into identifiable models that a user can identify with.
Okay, great. And there's one further follow-up question on that. This is from Raven, and they ask, are there any other UI approaches you've tried for this type of data? If so, why or why not did they work?
Yeah, so that's a good question. So how do you know when something's not working? I think is a thing. And I actually have found examples, like let's look at, come back here for a moment. I had a lot of trouble initially coming up with the source idea, and CloudMC lets you have multiple sources. So I could have different sources. I could have point sources all over, or I could have, different things as well. So it's already a one-to-many at that point. And then coming into this dialogue, originally it was going to be you would have an X distribution, and you would see what it is, and you would click a button, and you would be able to say change it from discrete to some other distribution. And it became unmanageable in the sense that you suddenly started having multiple pop-up windows, and that's like a red flag. Also, something we try to aim for, or I try to aim for, is try to minimize mouse clicks. Really use the user interface and try to enter the simulation data. And how easy is it to do, like in a simple case? How easy is it to do in a more complex case? And then eventually you sort of, like in this case, I just sort of came into this idea of you've got this editor, which then contains sub-editors within it. And this particular structure could actually keep going. It could nest another level if necessary. So I guess the short answer is trial and error. Really, it's you build a UI and you make a lot of mistakes, and you try to then basically eat your own dog food and then see how it works.
All right, I love it. Try a lot of things and make a lot of mistakes.
Yes.
That's how we learn. Awesome. Well, thank you again, Paul, for taking those questions right at the end here. Thanks again to our audience for attending. Look for us on YouTube. Join us on our Slack workspace, and we'll send out an email in about a week or so that this YouTube has been posted for publication, and you can watch it again or share with your friends. Thanks, everybody, and we will see you next time. Bye now.